Good afternoon, everyone. I hope you're doing great and you enjoyed the holiday. In some universities and colleges, today is holiday as well. That's what I guess the reason of not having many participants. So I try to quickly review everything for those who were not in the class or couldn't have enough time to review. And then we are gonna announce some of the stuff that we need to work on for tomorrow's labs. So if you have time and you can take care of those tasks, it would be great. You already have all the files that we are going to cover today and tomorrow. If you please go to the course content, the last folder that says today's content. Even if you downloaded before chapter 5a, I have updated this file today and I added another file, which is chapter 05D. So please make sure that you can download and drag and drop them to your Colab. And in the Colab, there is one prerequisite to start. So you can simply collapse down, as you can see, like this, and get to the part that is mentioned as pre-processing. So please go to that part. If you can download and bring it to Colab and everything works fine at your end, please type 2. You can also search for this data pre-processing. Thank you, Alvaro. Let's see what we wanted to do. For the first time, we wanted not to work with one of the predefined data sets like Reuters, Boston Housing, IMDb, and so on. We wanted to work with a real data set that was part of the competition in 2013. The original data set contained 25,000 cats and dogs images. We just took less than 10% of them, like totally 4,000, but we wanted to train our model using just 2,000 photos, 1,000 for cats, 1,000 for dogs. So we had a balanced data set, and we wanted to use validation as well as test data sets. So the first attempt that we had using the normal convolution, due to the small amount of data that we had, we could get to something like 70%. So sometimes I was lucky, I could get higher accuracy, but the range was between 70 to maximum 78. After that, we said, and we didn't have time to get to that part, what about data augmentation? And the question is, what data augmentation would do for us to get more precise results? The result went to above 80. Sometimes I was lucky, I got 87. So a huge progress, something like between 10 to 18%. The book said 14%, which is quite right for the examples that he showed. And we said, what if we want to just even go further? in one part of the book, it addressed that if we use regularization, we are going to get even better results, but there is a ceiling. We cannot go above 88%, even if we tweak the parameters that we have. But what about feature extraction with a pre-trained network or fine tuning? So this one is going to show us another jump from 80 some to 90 some. And even we can go further and get to something like 97%. And the result is way higher than what they achieved initially in 2013 with almost 10 times more number of photos for cats and dogs. Apart from that, we talked about the fact that in deep learning models, what we have is repurposable, and that is why we can use other networks that already pre-trained, and we are gonna shed light on these features, reusability of the data sets that we have. So I have already provided for you the data set, and hopefully you had a chance to go through the data set and upload it into your Google Drive, because the code app that we are going to work with is going to connect to that one. This is the part that we discussed. We used operating system. The original data set is Kaggle original data that we put the whole 4,000s there. And then we created the major cats and dogs small directory, and we made that. Then inside cats and dogs, if you remember, we created the train, validation, and test. And inside each of them, we created cats and dogs, once inside the train, another time inside the validation, and finally inside the test. And this is the time that we show how we could generate those cat.0 all the way to 999. And we said that for every single file that you could have, join it to the original directory, which was Kaggle, you remember here, and consider that as the source. Then we need to have similar file in the train cats directory. So copy that from source to destination using this. We did the same thing for validation and for test. And we did the same thing for dogs. So technically, we should have 1,000 cats, 1,000 dogs in the training folder, well, in their separate subfolders, right? And 500 for validation for each of them, and 500 for test. So this is what the book said, the sanity check. And to ease the job and to see how these steps are working, I provided these files for you, and you can see file B and this file 5B, trying on a short data set. Instead of working on thousands of photos, I just picked 10 and I just created a dummy folder. You could simply just go through it and see how it works. This is for the sake of just testing. And the C file is the sanity check. So apologies. So you can simply check if the numbers that you see on your computer are similar to this one. It shows that you have all the needed files to start the rest of the practices. Okay, you can just simply, those who have done that before, I'm gonna just open a new collab. Let's just go through the sanity check quickly. Just while I have okay, this is what I created 10 days ago, just for the sake of this class, to make sure that all that we do are the same. So please bring the file, upload it, and then go through these steps. And connect it to your Google Drive that you have already all the files copied there. So it shouldn't take that much time. If you simply and quickly just use Shift Enter, you should get similar results the way that I see on my screen. So take your time, go through these steps, and those who already have done the copying to the folders, you should get similar results. So please just type 3 if you get similar results. Thank you. Good afternoon, Donald. Bruno, can you hear me? Okay. I need to talk to you at your earliest convenience on a quick session, and I will explain what the content would be based on a discussion that I had with Andrew. I would be thankful if you tell me what could be your availability when you have free time, so we can just talk for 5 minutes. Yeah, definitely. If you show up tomorrow, I'll be from 8 a.m. to 6 p.m. If you can join any of the classes before or after, and I have a free time between 11 to 12. So and you know where you can find me, right? Okay, so hopefully during this time, people could just go through these steps. And if for any reason you couldn't get the same result, please make sure that you watch the video of the previous lab, copy all the needed contents, because what we need to do for tomorrow would be the continuation of what we have started since last week. Okay, so I'm going to bring you again to this page. The convolution, the convnet that we have contains conv2d and max pooling layers. It's not always like that. You see that we started with conv2d 32, 3 by 3, and then ReLU, and the input shape is 150 by 150, and then 3 channels, red, green, blue kind of thing. And then you see that we have 32 different filters or kernels. That's very much like what you have done in the assignment number 3. And then the max pooling is going to downsample the bits. So instead of having 150 by 150 after we apply conv2d, so we have 148, 148, and then we are going to just bring it down to 74, 74, and then we do the conv2d again, so it's going to just reduce the size to 76, 76, and then we just do the max pooling and so on and so forth. But there is one thing that we have here. After finishing all these conv2d and max pooling, then we are going to flatten. We are going to flatten and make it ready for regular dense layers. In the dense layer, we are going to have 512. So you know that this is the number of neurons that we have in the hidden layer. And then the activation for the last layer would be sigmoid, because we want just to see if it is cat or dog. So we're going to have just 1 neurons. And for binary classification, we always use sigmoid for the last. So and if you just say model.summary, it's going to show you something like that. As I told you, 148, so 74, then because of max pooling, and then downsampling. I said 73, I was mistaken. So it was 74, then 2 from, it's going to be 72, then half of it, 36, and the same thing. And after flattening, the dense layer contained 512 neurons. And for the first time, we used something new. We said that we need to go through all the picture files, convert them to RGB, grid of pixels, and then we need to make them a tensor to be processed, and we need to scale them. So we can do all these things manually. There are tools that we can use, but there is just one all-in-one package that does everything for us. And that is actually inside the preprocessing.image. You need to import image data generator, and the data generator is something that we never used before. I told you it's like a truck that starts when you say that go inside train folder, it's not gonna tell you, okay, I see two folders here, which one do you want me to go and fetch the pictures? It is going to go through the folders and all subfolders to fetch every single file and then bring it out for you. So it says that Python generators that can automatically turn image files on disk into batches of pre-processed tensors. We use it something like this. So this is importing the image data generator. You remember we said we need to scale it to be in between 0 to 1 instead of, for instance, 0 to 255. That rescaling happens here. Look at this image data generator. I'm sorry. We rescale it there, and then we go to the directory. What is that directory? Train directory. And we fetch every single file and scale it to 150 by 150, right? This is another thing that we need to do. And then every time that truck is going to pick 20 pictures and place it inside a truck, and the class mode is binary. We do the same thing that you see we have done for train, for validation as well, right? We do exactly the same thing. You might say, what is generator? Generator is something that is going to return, but after each return, it's not going to terminate the flow of the program. So here, when you say, for instance, I want to have I from 0, right? So, well, technically, from 1, because first we add 1 into it, from 1 all the way to infinity. This one, while true, is going to get to this loop. So first it returns, but it's not going to stop there. It returns 1, then it returns 2, and so on and so forth. So technically, you do not have any termination point for it. And that is why you need to terminate it in this way or another. So whenever you call that generator, you say, okay, for every item 1, 2, 3 that you get from it, first print that. So it's going to start printing 1. And whenever the item is greater than 4, right? So for 5, that would happen. Then break, don't continue that, right? So that is why we are going to have 1, 2, 3, 4, and 5, right? Because 5 is greater than 4, not 4. 4 is not greater than 4. So we are going to have that. Then it goes and says 4 plus 1, 5, and it's going to print 5. That is why we have 5 here. But in that moment, 5 is greater than 4. So we have a condition to break an infinite, a non-stop, infinite loop. But we said, what if we want to just fetch one picture and one label? So we could just see how it works. We said, okay, let's go to train generator that we already know it has 2,000 photos, right? 1,000 for dogs, 1,000 for cats. And then we said, okay, get that photo, and we have a data batch that we created 150 by 150, the scale between 0 to 1, everything that we did. And that has a label that if it is cat or dog. So we want to see what it is. So it's going to, if I say that show me the shape of that, it's going to say, you know what, we have 20 150 by 153 channels, and we have 20 labels which has come from this line. by saying that, we get to this part and we said fit generator. I didn't mention that, guys. Fit, actually, anybody remembers what is the relationship between fit and fit generator by any chance? For those who came later, this is the code for the class. Okay, so fit is fit generator is similar to fit, means you're going to have some pictures that you want to relate them to the labels. And apart from it, you have validation there. You do the same thing. But remember, we have the steps per epoch. What is the steps per epoch? What is the role of that? We have we have 2,000 pictures. And in every time, then we said that batch size is 20. So every time we pick 20 of those pictures, very simple calculation. You need to do that 100 times to finish and to break and to get out, because you, after 100 steps, 100 rounds, you're gonna fetch all those 200 photos. So that is why here, if you look, we have something that says steps per epoch, which is 100 here, right? And for the validation, we have 1,000. So the number of steps would be half, right? And for this moment, we are going to save. And I already told you that Edge 5 is a kind of legacy. It's a kind of deprecated. Pretty soon, it's not going to work. And instead of that, we need to use a new command, which is, as you know, it's Keras. Let me just bring you there. Okay, you see that here it goes through epoch number 1. And in epoch number 1, we go through 100 steps. In every steps, we pick 20 pictures. And that is what I told you. So it's a kind of old, it is already showed you a kind of warning. And it says it's deprecated. So it's a legacy command. So use Keras instead. And for plot, I told you one thing, and today we are gonna elaborate more. I'm sorry. Sometimes you see that the accuracy works, sometimes you see that the validation works, sometimes ACC works, and sometimes val underscore ACC works. So why we don't have any consistency all the time to know what to put in the history and so on. We have one command that shows us the dictionary, and actually the name is self-descriptive. You're going to see it in a few minutes. And it is going to show us what parameter I should pass to acquire, to get validation accuracy, the training accuracy, and so on and so forth. So longest story short, if you get any error here, don't worry. There's just one line of code that you can simply find out what is the appropriate parameter you can put there to resolve the issue. So for this one, it was the first attempt. And anyone wants to step in and say, what is the major issue? Just the keywords would be enough. Tell me, what are the major issues that you see? These spots are training and these continuous lines are validations. So here is the accuracy and the other one is the loss. So what can you infer from these two? Parsa, do you want to step in and say anything? What is the major problem that you see here, guys? High fluctuation is one of them. Yes, correct. What is the other problem? So Parsa, if you look at here, we get to something like 74%. And here we have one epoch in epoch number 22, which is 75. Which one makes more sense based on the accuracy graph? To stop it at 8, at 10, these two are the maximum, or at 22, which gives us higher? What do you think? Anybody else could step in and talk and help Parsa? Okay, Parsa says 22. Who else? Donald, what is your guess? Anand, Yang, UI. UI says 8. Is it 8 or 10? The question is, which epoch is the best to terminate and say goodbye, to say that the model is the perfect form with the parameters that we have? You see, 8 gives us 74, 10 gives us 74, and epoch 22 gives us 75, even better. Which one do you think? UI said 8 or 10. While Parsa said 22. So that is the time that we should go and use the other graph, which is about loss. Guys, look at this one. Here in the 8, we have the minimum loss, right? Yeah, in 8, we have minimum loss. Even in 10, we have a slightly higher amount of loss. Does that make sense? Not very much, but so we could say, as Huai said, 8 or 10 would be fine, but even among those two, we have less loss. And actually, even if they are the same, how many epochs we need to go through it to have less time? So 8 would be more preferable, right? You're not going to gain anything, even if they have similar things. By saying that, we get to the next part. Guys, can you please confirm? And I already corrected that, but I'm going to show you what else. Now, the next part is, okay, let's do something better, and that is data augmentation. For data augmentation, I have already told you that we want to have more samples, but when it is not possible, we need to get the most out of the current samples that we have. That's a nice way of saying, as the book said, and in some other references, they say we want to remix the current pictures. The good thing is, yes, it is going to provide for you some more examples, but the downside is technically you still deal with some samples that are highly correlated with each other. Guys, do you see the dilemma here? From one side, you have more samples if you just augment, if you use augmentation. But at the same time, the photos that you're gonna provide as the augmented folder that contains like 20 times more pictures, they are highly correlated with the original data. Okay, if you get that point, please type 1. Positive, you make more examples. Not very positive, the data that you have received are very much correlated. You remember we talked about that in the previous example. That's not very much favorable to have super correlated features, right? So should we prohibit such a solution, or do you have any remedy for that? Is it possible to cancel, guys, listen to these words. Is it possible to cancel the super high correlated relationship that we have in augmented directory? Is there a way? What is the correlations result conspiracy? Remember, what is the way that we could drop the conspiracy? Anyone can remember? I intentionally use the words. How can you drop the conspiracy? Do you remember Jeffrey's Hinton example? Yes, parser, drop out. Exactly. Let's just get there. I just want to put all those dots and you connect them together. So overfitting is caused by having too few samples to learn from. That was last week's quiz. And I want to ask you, would you please, any one of you, go to the quiz folder, to assessment and quiz folder, and see if it is visible, and can you start make it. Just give me a second, I'm sorry. Okay, can you please go to quiz and see if quiz number 10 is visible for you? Okay, but please, my suggestion is wait till tomorrow's evening when we cover everything, so you can have better understanding. And okay, so please just wait till tomorrow's session. Yeah. Apart from it, I bring you to websites that I have provided for augmentation. One of them is this one. You see that here we have one cat picture, and we do different way of augmentation, right? So from, you see that, for instance, we cropped, we tilted, we shifted the position. So this is going to enlarge our data set. And the idea is we just see, I'm gonna tell you, look at this one that I didn't highlighted them. The goal is that at training time, your model will never see the exact same picture twice. And that's a key point. It means every time you're gonna use one of the remixed version of the original picture samples. It says that the data augmentation takes the approach of generating more training data from existing training samples by augmenting the samples via a number of random transformation. We watched a YouTube video and you have it there too. So you can, if you missed that video, I strongly recommend please watch this 12-minute. It tells a lot. And I have provided in the collab 2 links. We watched one of them just a second ago. So look at this one, for instance. If you have number 6, you see we have lots of transformation of the original one, but there is a problem. Look at, for instance, this one. If you don't pay attention to the translation, that it is going to be very close to number 9 as well, and it's going to give you not a proper result. Also, do you think that if we have horizontal flip or vertical flip, is it going to be useful? We asked that question in the previous class, and the answer is no, because then it's going to give you not acceptable results. It's going to give you, look at the things that we have. For instance, we have flip, but we have 2 types of flip, horizontal or vertical. We have rotation, you saw them. We have a scale to magnify, to zoom in, zoom out kind of thing. We have the crop from the original. And these are the things that even you can add noise. These are the things that we normally use to augment the data set that we have. Getting back to image data generator, till this moment, we just said 1 divided by 255, but that is just one thing that we did. We could do all these things. So randomly, each time we are going to get one version of the original picture when we get to this one. And that is why it takes almost double the time, because we have to do these, we need to take care of these processes. So it's a time-consuming thing. But the good thing is it is going to enrich the data set that we have while we suffer from a lack of examples. So it talks about all the possibilities. The hardest one to get is the shear. And if we go to this, this is a definition for the shear. So we are going to, it's like distorting the shape towards Y or X axis, right? And I talked about the flip, horizontal or vertical. And these are the 2 web pages that I have told you. And by saying them, we get to the beginning of this test. Look at this one. This is a little bit confusing at the beginning. So that is why I broke it down to some steps for you. And let me just show you something. Look at this. If I say that from Keras preprocessing import image, I say go to the directory of X, Did I run the code above? I'm not sure, so it might give me error, but I ran that last night. So this one is going to show you, if you uncomment this, X is going to show you from 0 all the way to the end, but I don't want to fill the screen with all those samples. That is why I said for every A in X, just print that. And if I just picked cat5, after printing cat5 JPG, just break. So it just shows a few number of files that we have. Look at this one. We do the same thing here. I just, instead of using a lengthy name, I just said join the train cat directory with A, right? So we have in my file names all these from 0 all the way to 1,999. Well, 99, because there are two categories. So for cats from 0 to 999, and for dogs the same, 0 to 999, totally 2,000. My apologies. I need to correct. The number of pictures would be 2,000, but the indices would be from 0 to 999. And that is why we join every one of those file names to look at this one, to the train cat directory and train dog directory for all those things. And just for the sake of this toy example, I picked cat index 4, cat 4 JPG. That's the fifth picture in the cat directory. And I added these lines last night first to see what is the original picture, what does it look like, and then I applied that scale 150 by 150. So it turned it to this one, right? And after that, this is what we are going to continue tomorrow to see when you run that to make augmented. Look at this. This one, the head is towards left, but here we have a vertical. This one is towards right, again, towards right, towards right. And I ran that again, so we could see that two of them, they look right side, two of them, they look left side. So we are going to continue tomorrow by working on this in the class. I strongly recommend that you follow all these steps. If you can't understand what is happening, that's what we are going to explain tomorrow. But the good thing is, give it a time to be rendered, to be done, especially the last file that you see, file number D. It takes like 8 hours to be compiled. So run everything on file D and make sure that it works. So tomorrow we don't have that time. Even if you start early in the morning, the results would appear sometimes around 4 o'clock. So please run it and just come to the class with all the results. I'm not going to take your time more. Thanks for coming to the class. Just Bruno and Huai, stay for a couple of seconds. And I'm going to just terminate the video here. I stop sharing and I stop recording. Thank you very much.